Hi, Assalamualaikum everyone. My name is Sofia Aidura bin Pizaini. As for my mini project, I will explain projectile motion in skateboarding. What is projectile motion? Specifically, skateboarding is governed by physics principles such as momentum, gravity, centripetal force, friction, and lastly, the topic of interest of this project, projectile motion. Definition: projectile motion is a form of motion experienced by an object or a particle, a projectile that is projected in a gravitational field such as from Earth's surface and moves along a curved path under the action of gravity only. As you can see here, there are two components of the projectile motion, which are horizontal and vertical motion, and the variable affecting are time of flight, final velocity, launch height, and horizontal range of the projectile. This is the program that I did under the title of Projectile Motion in Skateboarding. I'm going to look through one by one all of the components and their names. The title label here is a component, J label. The panel, I name it as plot panel. The spelling has to be precise as Java is case sensitive. Yet again, initial velocity and angle of takeoff are J labels. The text field for initial velocity, I name it as init velocity, and the text field for angle of takeoff, I name it as angle. The units are J labels. The text area here is named as txt output. This area here will display the value of max height and max range later on. The run and clear button are button components. This run button is where the formula of projectile motion will be applied. Let's look through the coding under urusan Java plot. This is where the graph of motion will be displayed in plot panel. Next, we are going to look at action performed by run button. The components in init plot are set with these small values that I preferred. This is because the X component, velocity of a person, is not as high as machines, and same goes to the Y component. The clear button here only applies to txt output. By looking from the video, I assume the average speed is 5.5 meter per second and the angle of takeoff is 75 degrees. And then we run it. The values shown here is considered acceptable because the height of the cone is roughly 1 meter, and the boy can overcome it, which implies that the max height must be above 1 meter. Let's say if the boy wants to go higher and further than that, he must go faster than before, which I put the value of 6 meter per second. We can see the result of max height and range increases. If we change back the initial velocity to original, which is 5.5 meter per second, and the angle we reduce it to 65 degrees, we can see that the max height is the lowest and max range is the highest as compared to the values above. Of course, the calculations cannot be done with numerical figures when doing physical sports. You have to go through a lot of trials and errors in real life until you learn from it. I hope this program could help you visualize the basics of physics applied in sports, like how fast you must be, how high you must jump, how much downward and drag forces need to be executed, and so on. That's all from me. Hopefully my video benefits all of you. Thank you!